Happy Monday. Welcome back. How was your weekend? Did you do anything fun? I didn't. I relaxed, but it was much needed. So it was a great weekend for me. I hope you're doing well today, and I hope you're ready for Number Corner. We're not doing any new workouts today, but we're circling back to Megan's Marbles. Remember that problem you guys did last week? I helped you talk through it. Some of you worked through it on your own, and I said, we're going to talk about it in a few days. I even gave you a challenge problem. Well, I saw some of your work, and I want to talk about it. Before we do that, though, we have to do what we always do. Update our calendar grid really quickly and update our calendar collector. So here we go. Today's the 14th, but before we look at the 14th, let's see what's happening on the weekend. What do you think it's going to look like? You think Sunday's going to look like? So what do you think today's going to look like? I'll give you a second to think about it. Right, here it is. Ready? Interesting. Well, you know what we have to do now? We have to add this observation to our observation chart. So let's go there. Here's our observation chart. Today is the 14th. And I'll come back in and I'll add the symbols later. But let me show it to you one more time so that we can figure out what our modern number is going to be. Remember, the scroll is 100. The horseshoe is 10. And the staff is 1. And they actually call it a heel bone, not a horseshoe. My apologies. So we have a scroll, 5 heel bones, and 4 staffs. What number is that? Right, 100. And then this would be 50, and this would be 4, 154. So I'm going to add that. Now we did skip some days in between, so I could come back here, and I probably should add September 12th and 13th, because this does not fit our pattern, does it? 121 plus 11 is definitely not 154. So I'll have to come back in and fix that. But for the sake of time, we're going to go ahead on to Calendar Collector. And when we look at our calendar grid observation sheet again, you'll notice that it was updated. Let's do Calendar Collector. Well, today is the 5th day of school, and we have 2 feet so far. Yikes. We have 24 inches, right? Yeah, right. 6 plus 6 plus 6 plus 6, or 6 times 4, 24. Now we need to add another one. Now how many inches do we have? Yeah, 30. Now how many feet is that? We had 2, now we have what? Right, 2.5. If I were to describe this using fractions, how many sixths do we have? We know that 1 6-inch piece is 1/6 when you compare it to a yard. So we have 5 6-inch pieces. What fraction is it? You got it. 5/6. Very good. All right. So today we are going to talk through Megan's marbles. So open up your Number Corner workbook. I think it was on page 10. If you don't have your Number Corner workbook with you, remember we talked about that was fine. All you needed was a piece of paper, and you should have labeled the top Megan's marbles. So let's talk about how you solve that problem. All right, I have my whiteboard here, and I'm ready to share with you guys one of the ways the student solved this problem. Would you like to know what they used? Now, if you remember from our last video, I showed you guys how you could use sticks and dots or base 10 blocks to solve the problem. This particular student didn't use that, but they still arrived at the answer, which we'll talk about the answer in just a second. They used, anybody want to guess what that is? They used a number line. You're right. And on their number line, they skip counted. Want to guess what they skip counted by? Maybe I should just show you. I'm trying to make these partitions as equal as possible. So if they're not equal, forgive me. Okay. What did they do on this number line? They counted by 14. Why did they count by 14? So you might remember what our original problem was. Maybe I should start there. Right. It was 14 times 9 equals, now we're going to just put a unknown there. I guess we'll leave it like that. Make it bigger. 14 times 9 equals something. I might even put it down here. So if they counted by 14, how many times should they have counted by 14? Right, 9 times. So how does that actually represent the problem? 3, 4, 5, 6, 7, 8, 9. So what answer did they get? 126 is 14 times 9, 126. Did anybody get anything different? Right, it is 126. And you may remember last time we talked about an estimate, and I asked you about how many marbles do you think he has? And some of you said 90, because 9 times the 10 and 14 is 90. And others of you realized it was going to be more than 90, because 14 is more than 10. And 126 is more than 90. So you're right. It is, but let's do some more work to prove that to be so. Now, I asked, how does this represent the story problem? Right. So Megan had 14 marbles, and Patrick, was his name Patrick? Yes. Patrick had 9 times as many, so I had to count 9 groups, count by 14 9 times. And that was an absolute okay way to solve the problem. Good job. Let's talk about another way you could have solved this problem. All right, I went ahead and have created our problem here for you. 14 times 9 or 9 times 14, we know that our answer is going to be the same, because I want to talk about how students solve this problem. So let's talk. Now, I want you to make the effort to understand what this student did and why they may have chosen to do what they did. Okay, so we have our dimensions, and hopefully you know what a dimension is now since we played our game Splat the other day. Dimension of 9 and a dimension of 14. I can, or at least I saw the student do this. Oops, I'm moving the wrong one. Is that okay to do? Are we still solving the same problem? Did we add any squares here? No, it's the same area. And even though our problem is asking about marbles, we could think about this as a row of 14, so that's one set of marbles. And then we have 9 sets of those marbles. So now we have 2 different problems. And if you see here, I'm kind of highlighting which problem I'm talking about using the distributive property. It turns colors. So here is 9 times 10. So what is 9 times 10? Right, 90. And that's actually what some of you predicted our answer would be close to. But we knew it would be more than 90 because we also had this 9 groups of 4 over here, right? Right. So 9 times 10 is, we just said, 90. What's 9 times 4? Right, 36. So now we would have to do what? 90 plus 36. And we can do that fairly quickly and easily, right? 0 plus 6 ones is 6 ones. 9 tens plus 3 tens will give me 12 tens, which is 126. Did anybody else solve it like that? Did you use the distributive property and break 14 into 10 and 4? Oh, you did something similar, but instead of 10 and 4, you did 12 and 2. Is that going to give us the same answer? Are you guys familiar with your 12 times tables? Well, if you're not, would you choose to break 14 into 12 and 2? Right, maybe not. Okay, let's talk about another example way a student solved this problem. All right, here's what I've seen another student do. I want you to take a moment and study this. See if you can figure out what the student did and maybe why. Right, who can tell me what they think? What do you see? Yeah, they did 10 times 14. How can you use 10 times 14 to solve 9 times 14? Well, 10s are fairly easy, right? Right, because it's increasing by a power of 10. So we know 10 times 14 is 140, right? But our answer has to be smaller than that because are we actually doing 10 times 14? No, which is why you see this 1 is here. What are they doing with separating that 1 right there? Right, they're actually subtracting that 1. So I'm going to put a subtraction sign here. And what actually are they subtracting? Are they subtracting 1? Right, they're actually subtracting 1 times 14, which is 14. They're subtracting a group of 14. So, line that up. They're subtracting a group of 14 because we know that he doesn't have 10 times as many marbles. He only has 9 times as many marbles. That means I'm actually doing what? What is the problem I'm solving here? Yeah, 140 minus 14, which equals still 126. So it looks like we're proving that our answer is 126. And I can even do this. I can cross this out. So y'all know I'm not really considering that, or the student didn't really consider that for their answer. They just used what they knew about their 10s facts in order to solve it. So if you have 10 groups of 14, take away 1 group of 14, essentially, what problem is that? You got it. 9 times 14, which is 126. All right. So I showed you a few different strategies that you could use to solve problems. We talked about a number line, where you made your group. It was a group of 14, and you counted by 14 for however many groups you had, which is 9 times as many. So you count it 9 times, starting from 0. We talked about how you could use other known facts to solve a problem. And the known fact could be where you add a group on because maybe it's close to a 10 or a friendly number. You do a known fact in this sense where you use the distributive property. So if you need to take a moment, pause this video so you can jot down some of those notes or maybe draw some of those other examples in your notebook. Because we're going to do another problem. Right? You're still not ready. You can pause this video. Don't forget that because we're going to move on. And we're actually going to look at another problem. We talked about how when you're solving problems, communication is huge. Okay? So you need to be able to read the problem, understand what's happening so you can restate the problem, find the critical information, choose a strategy that you can then execute, and then explain your thinking. And we kind of did that whole communication. We walked through all those steps together. Last time we read the problem, I had you restate the problem. We found the critical information. We talked about which strategy we were going to use. We drew a model to solve the problem, and then we explained our thinking by looking at all the different types of strategies that could have been used to solve the problem. So we're going to do another problem, and I challenge you to use one of the strategies that we just talked through today to help you solve this problem. But first things first, you got to read the problem, right? So here we go. Okay, I'm going to read it out loud. After several weeks of collecting marbles, Megan has 12 times as many marbles as she did when she started. How many marbles does Megan have now? So, restate the problem, guys. And this is going to be a part of your homework or work that we're not going to do together. I want to see that you can take what we've done together and apply it independently, okay? So restate this problem, even if you have to say it out loud to yourself. And then I want you to underline, in your notebook, underline the critical information. I believe this is on page 11. It says, write an equation. Remember, an equation has an equal sign and an answer. And right now we don't know what it is. So you have to use a letter to stand for that unknown quantity. Draw a picture. Use one of the models that we've done today. And I can't wait to see what you've done with it. I do want to end our video today with this. Last week I gave you a challenge. I said, if you were able to solve that problem quickly, and today, as we checked our answer, you know you got the right answer. I gave you a challenge, and I said that Patrick had a friend, and his friend's name was Elise. And Elise had 4 times as many marbles as Patrick. So, if you solve that problem, then stay on with me for a second so that we can talk about the answer. And if you didn't solve that problem, it's fine, because now you have another problem to solve using the strategies that we've worked through and talked about together. So good luck. Have a great rest of your afternoon, and I'll see you the next time. And if you're staying behind, then let's talk about it. Now that we know Elise had, or Patrick had 126 marbles, Elise has 4 times as many. So that means I'm going to be doing what? Multiplying. We know Patrick has 126. We know Elise has 4 times as many. So here is our equation. And I'm going to make it pretty big. 126 times 4. Let's estimate. What do we know our answer is not going to be? That's a good thought. It's not going to be 126 because she has 4 times that amount. Very good. So about what could our answer be? You say 500? How do you get 500? Oh, You thought about 126 as 125, like $1.25. It's good thinking. We're going to draw a rectangle here. And I know it's not perfect, but we're trying to do this quickly. I'm going to make this side 4. Remember, this was 126. Somebody said earlier they can think about it as 125. And we can easily do that because we understand 125 is $1.25. And if I put that together, that's $4 for the $1.25, $1.25, $1.25, $1.25. So that's $4. Then we have 4 sets of 25 left over, which is another $1. That will be 500 here. So what I actually did was 125. Now we have to have one more group of 4. 504. 4. We could just simply add 126 4 times. And we will, in fact, get 504. So if you got 504 from this challenge, great job. I appreciate you sticking with me this long. Have a great rest of your day. I'll see you guys tomorrow. Bye-bye.